Most of the times here you are given a number of quantities and you are asked to establish a formula connecting them. Kwa mfano, consider ulikuwa unatembea, umeona, ghafla ukajikwaa, then ukaanguka, ukaumia. Now the question you are wondering, labda wewe ni mpenda physics sana, ukawa unajiuliza kwamba nilivyoumia hivi, hii pain inaleti vipi? Inaleti vipi na uzito wangu? Kwa mfano, ningekuwa mnene zaidi, ningeumia zaidi au ningeumia kidogo? Kwa mfano, ningeanguka kutoka umbali wa juu zaidi, kwamba height ambayo ningeanguka ingekuwa juu zaidi au ingekuwa lower zaidi, hii pain ningeumia zaidi, ninge hurt hapa zaidi au nisinge hurt? Umeona? Kwa hiyo hapa nataka kujiuliza time taken to reach the ground. Unajiuliza hivi vitu vitatu vinalete vipi hapa? Umeona? Kwa hapa tunaweza tukaassume kwa vile kuumia pain sio physical quantities. Kwa hiyo tunaweza uka make to a simple assumption kwamba this pain maybe is equivalent, not maybe, actually is equivalent to the pressure ambayo ungefall. Now we know that the higher the pressure ambayo ungefall, the higher the pain. So automatically when we speak of pain, we speak of pressure. So now here, how many quantities do we have? We have pressure, the first quantity. We want to know how this pressure is related to the body mass, how this pressure is related to the height, how this pressure is related to the time taken to reach the ground. So we have 4 things that we want to find the relation here. So if pain is direct proportional to pressure of falling, the first step to tackle such questions, you have to define the symbols for your quantities. Kwa mfano, for this case, mimi ni let P stand for pressure. Body mass iwe represented by M, na height of falling iwe H. Time taken to fall iwe represented by T. Baada ya the importance of defining symbols ni pale ambapo kunatumika symbols ambazo ni confusing. Kwa mfano, unaweza kwenye swali ukawa umepewa P inamaanisha labda any other quantity, labda density, umeona, lakini wewe kwa mazoea ukaenda huku kwenye calculation ukatumia P kama pressure, lakini hii itakusaidia wewe unaangalia what did P stand for, ni pressure, na kusaidia wewe kutopotea on the way. So the second step, unatakiwa uandike an expression assuming that these 4 things, the other 3, kwa sababu hapa tunabidi tofautishe kwamba what we are looking is the relation between pressure and the other 3. So lazima tuoneshe equation, tuandike equation kana kwamba the 3 of them are relating direct proportional to pressure. Kwa tutaandika expression as if kwamba the 3 factors are direct proportional to pressure. So pressure is direct proportional to M raised to a certain power, unaleti iwe X, na H ambayo ni height is also direct proportional to pressure lakini raised to power fulani Y, na X is direct proportional to time raised to power fulani ambayo tukaita nini, Z. So kuondoa hii proportionality constant tukuondoa hii proportionality symbol tunaweka hii constant K hapa. So tunasema P ni sawa na K times M power X H power Y times T power Z. Tuko pamoja? Equation ya kwanza, show me, times T power Z. Our third step requires us from the principle of dimensional homogeneity, na tuambia kwamba for this formula to be correct, dimensions are left hand side, dimensions are pressures, natakiwa hizo sasa dimension ya hii product ya hizi quantities on the right hand side. So the third step tunachofanya ni kucompare side. Kwa tutasema the left hand side tuna pressure, the left hand side tuna pressure P ambayo ni pressure. Tunajua units za pressure. Actually we are interested in the dimensions. Kwa tunajua pressure ni force over area, kwa haraka tu force ni mass times acceleration, LT dimensions zake acceleration hizo hapo, divide by area ni L. Finally we have dimensions of pressure ni ML-1 times T power -2 2. Similarly, kwenye right hand side here we have m standing for body mass. We know dimensions are m ni mass. We have h for height. We know dimensions are height ni length. So we know h stands for length. And we also know that time, dimensions are t, ambayo ni time ni t2 ya kawaida. The first step ni rewrite the equation 1 ambayo tumeirewrite hapa kwamba dimensions are p from the principle of dimensional homogeneity. Dimensions are p sasa dimensions are the right hand side. So dimensions are p ni m, l ni 1 in mass, -1 in length, -2 in time. While the right hand side, here we have times t. So on the right hand side we have m times m power x, l power y na t power z. So dimension lazima ziwe sawa za left hand side na right hand side. Tukisha andika hayo, nabidi tuanze kucompare value moja baada ya nyingine. Kwa tutaanza kucompare masses. Kwa tutacompare mass na mass hapa. We know that from the principles of exponents, if things have the same base, automatically they must have the same exponents in the two sides. So if m huku power yake ni 1, so we know that for m the left hand side ni 1 ni sawa na the right hand side ambayo m ni power x. So x is equal to 1 automatically. The same way kwa kucompare for l the left hand side ni -1, while l the right hand side ni y. So we automatically have y is equal to -1. Similarly for time, in the left hand side we have -2, while in the right hand side we have z. This is z here, this is z. So automatically we have we have z is equal to -2. So we have z is equal to -2. So we go back to equation 1. And instead of these values, the x, instead of these letters x, y and z, we plug in their respective values. So for x it will be 1, for y it will be -1, while for z it will be -2, as I've written here. Comparisons are sawa na k, m power 1, h power -1, t power -2. So kuziandika vizuri ku eliminate these negatives and negatives. So ikiwa power negative actually you divide. So p ni sawa na k times m h t squared divided by h t squared huku chini. You might ask me a question, what happens to this k? Why is k still here? What is it doing here? Kwa nini yenyewe haiondoki, bado ipo? Well, for most of these questions what tuna assume k is dimensionless constant. It has no any significance hapo. It might just be a number, maybe 5 or 4, which has no any dimension. So automatically it has no effect. You put it, you don't put it, lakini eventually you have to put k there to show that this formula is limited by certain constants. Unless otherwise, nasisitiza, unless otherwise, in some questions you are given the units of k. You are given the units of k, and for such questions you have to consider k as a quantity, because na yenyewe inakuwa na units. So at the point ambapo hapa k, simona hapa k, kuanzia hapa tumeiondoa kwa sababu haina significance, lakini k na yenyewe ingekuwa na significance, tunge multiply dimensions zake, zingekuwa na dimensions fulani na zenyewe zina power na vitu kama hivyo juu. If k ungepewa ina units. Other examples, kwa mfano common question ndo zinakuwa kama haya, sio magumu sana, ni max za bure, niwe kutulia, tunakuwa makini. Velocity v of a sound through a medium may be assumed to depend on the density of the medium and modulus of elasticity. Ukishaulizwa swali kama hili, inabidi utofautishe kiini cha swali ambacho kinatakiwa kiwe subject quantity gani. Kama hapa ameshakwambia velocity v depends on the others, depends on these, so v tayari ni subject. So automatically okay, tumalizie swali. Depend on density hapa of medium and modulus of elasticity. Kwa vile hamjasoma elasticity so far, I assume kwamba this is the first lesson. Elasticity ni topic ambayo iko mbele kwenye properties of matter. Ndio maana ameamua hata mwenyewe kukupa dimensions zake ili ku avoid any inconvenience. So deduce by method of dimensional dimensions the formula ambayo ina relate hizo quantities hapo. Solution kama nilivyowaambia mwanzo, first you define symbols. Kama hapa uzuri ameshakupa kabisa symbols hizo hapo, then you assume kwamba they are all directly related to v. So utaweza kuona hapa ameandika v is direct proportional to r raised to a certain power. You can let any letter a, b, c, d, whatever, x, p, q, any letter. Again v is direct proportional to, so you combine ni kwamba v is direct proportional to density raised to a certain power, hiyo hapo, and v is direct proportional to e raised to a certain power hapo, and this should have been density. Typing error. So finally you have the expression there, labeled equation 3. So writing the dimensional formula of v na hiyo hapo. Kwa the next step ni kuandika dimensions zake. Kwa utaandika dimensions za, ndio ile step ambapo mimi kule mwanzo nilikuwa nimekuandikia nini? Nilikuwa nimekuandikia hapa nilikuwa nimekuandikia the fourth step ufanyaje? The third step uanze ku compare side, left hand side na right hand side. Ingawa yeye kwenye huu mfano hapa ameruka automatically amezifanya juu juu, hata ukishakuwa mzoefu baadaye unaweza kuzifanya tu juu juu. Nimeweka zile step ili kukuguide as long as najua ni beginner. So baadaye utazoea, tutakuwa unaziandika mwenyewe kama hivi, ukizingatia pawa nao muda ni mchache, kwa kusave muda unaandika moja kwa moja. So in the left hand side we have the velocity ambapo dimensions zake ni lt minus 1, while as I said kwamba constant where we assume that is dimensionless constant, so we ignore the constant there. So dimensions the density ni sawa sana na mass over volume. Kwa units zake ni kilogram per meter cubic. Kwa automatically dimensions zake zitakuwa mass m l power negative 3. Ndio maana ameandika hapa mass l power negative 3 ambazo zilikuwa raised to assumed power ambayo ni a. Similarly kwa modulus of elasticity e ambayo units zake tulikuwa tumesha pewa hapa, ambazo ni ml power negative 1 t minus 2. Kwa ni hapa power raised b ambayo tuliassume huko. So automatically after that make sure for this case ni tofauti na ile kidogo ambayo ile ilikuwa simplified, lakini hapa baada ya hapa combine powers, combine the powers iwe rahisi kwako kufanyaje kusolve. Combine powers, combine the powers. What I mean ni kwamba collect all the m's ili usimplify terms zako, kwamba hapa it will be m a times the powers with the same base. Unafanyaje? Unazi add. Hiyo ni principles za exponents, kwamba the same m hapo, the same m hiyo hapo inakuwa ni a plus b. Similarly unakuja kwa l inakuwa negative 3a plus kwa l negative b. Kwa unaweza kuona hapo ni negative 3a minus b. Similarly kwa t, huku t hamna, kwa inabaki 2t minus 2b. So finally unachotakiwa kufanya ni kuanza sasa kucompare m ya kule na m ya huku, l ya huku na l ya huku. So in comparison tunaweza tukaona kwamba from m, this is from m, we have a plus b on the right side, from the powers of m on the right side a plus b, while the powers of m on the left hand side ni 0. So we have a plus b is equal to 0. Is it clear? I hope it is. So similarly tunakuja kwa l ndo huyo hapa, kwamba on the right hand side l tuna negative 3 minus b, while on the left hand side l na power 1. Similarly tunamalizia kwa t, kwamba t on the right hand side negative 2b, while on the left hand side ni negative 1. So automatically from here we have our b value already, kwamba b is equal to a half, while from here we can get a if we have b, kwamba a is equal to minus b, so automatically a itakuwa minus a half, tutaona huko. So you go on solving for values of a, b. It doesn't matter any way that you are going to use. Kwa kutumia calculator unaweza, bahati mbaya hatupo physical, lakini calculator unaweza kaingiza hizi value ikakupa value zote automatically bila kuhangaika, na inaruhusiwa tu kabisa, vizuri kabisa, ili mradi sio bam in physics. They don't concentrate much in the mathematical part. So in whatever way kama huyu alivyo solve hapa, lakini finally you have to find the values of a, b and c. Actually c is not here, so you have to find the values of a and b. So we have values of a ni negative half and your values of b ni a half. So you go back and substitute these equations. You go back and substitute the exponents up, the values of a and b in this expression. Then you get v the density power a, where a is a half, and actually negative a half, and b is half. So finally you put in the values, you find that the velocity v, you see now I wanted to call it volume, the importance of defining symbols, you might think v is volume. You see now this is the most common mistake ambao wengi watu tunafanya na tukosesha errors and dimensions, makosa madogo kama haya. So we have our velocity is equal to density power a half, e power density power negative half, e power a half. So ukiziandika in good mathematical terms, you find that v, returning our constant inside there, is equal to the square root of e divided by density, whereby the square root means power half. So on top here itakuwa power half, on down here itakuwa power half, lakini since divide ndo inakuja hii negative half. So the constant of proportionality is usually found to be 1, as you remember this formula. Actually k is 1 and it's not our interest there. You might put it or ignore it, doesn't matter. So we have another example. Assuming that the frequency v of vibrating string depends upon the load f, the length of the string l, and the mass per unit length m, prove that this one. So automatically ni kama na wenyewe wanakuambia uderive formula, lakini this is the kwamba wameshakupa jibu, so automatically lazima end na jibu kama hili hapa. Maswali yanaweza kawa aina mbili, kama hapa amekwambia uprove. Swali lingine ambalo angeweza kukuuliza, ambao ni application yetu tutaona, ni to prove the consistency, kucheck kama hii formula ni dimensionally correct, kama ina exist, kama kuna formula ambayo inaweza ikakaa hivi. So the first thing kama tunavyofanya, tutaangalia nini ambacho kinatakiwa kiwe subject out of all these quantities ambazo wametutengea hapa. Kwa tunaona hapo kwamba our subject should be v, because the one which is related, which depends on the other three. So kama kawaida, we show them that this subject is directly proportional to these other quantities, so we raise them to certain powers, about tuonesha v is directly proportional to f power fulani, ambao we just let any letter a, b, c, x, y, z, whatever, p, q, r, s, whatever. So it's also direct proportional to l, direct proportional m. The first thing you remember, you have to define the symbols. Frequency v for this time, you might think it is velocity, or you might as well think it is volume. Who knows what mood will you be? So be careful that you observe these symbols. That's why I insist that you should always remember to define your symbols. So finally, after that, you get a combined expression that v is equal to that one as it is seen, where k is constant of proportionality. Substituting the dimensions that our step required us from here to compare the left hand side and the right hand side. Now on the left hand side we have v, where our v was frequency. We know that frequency is per second. The units of frequency is per second. I hope we know this. Apart from hertz, those are complex units, but when you return them to the normal fundamental units, it's per second. So frequencies, the units is per second. So automatically dimensions of these dimensions zinakuwa ni t power minus 1. So ndo maana ameandika hapa t power minus 1 hapo. So on the right hand side tukianza na f ambao ni load applied, ambao ni force, in other words ni mass times acceleration. Hii ni mass times acceleration, lakini in brackets raised to power a, ambao ni hapa tulilete huko. Similarly for L, ambao our L ni length ya string, so it's just length, L raised power b, ambao b tulilete huko. Similarly to the final, ambao ni mass per unit. You see the importance of defining symbols. M you might just think is mass, but this is mass per unit length. So the dimensions are of mass per unit length. The dimensions mass per unit length ndio hii hapa, mass per unit length raised to power c, ambao tulilete hapa. Finally you just collect all the m's together, the powers of m's, all the powers of L together, the like terms, collect the like terms, and you get that m, these are raised to power 0, these are raised to power because they have no any way here, ndo maana hazi exist hapa, ni kwamba their values are 1 1 1. Kwa hiyo inakuwa ni m power 0, L power 0. You can just put them or don't put them, automatically just remember ni powers za 0. So automatically just compare m na m. As you can see that from here, this is from m, that on the right hand side ni a plus c. Ukicompare na m on the left hand side inakuwa ni 0. Similarly this comes from value ya t. Ukicompare value ya t on the right hand side ni -2, well value ya t on the left hand side ni -1. So we have -2a is equal to -1, where from here we can just get simply a is equal to a half, as you can see. So similarly this is from t, and from L we have L on this side is a plus b minus c, while we have L on this side is 0. So a plus b minus c is 0. As from here you can solve anyhow that you can, but find the values of a, b and c. The mathematics doesn't matter here because they don't mark math, this is physics. So you find the values of a, b and c. Finally you come and substitute them on this equation 4, where now you have the value of a is a half, the value of b is from here is -1, the value of c is -1/2. So finally you can just conclude your formula that we have the k is useless there, you can put it though. F ni power a half, as I said. A, the value of a is a half, and L power -1. The value was b, and b was -1. Similarly to m, -1/2, it was the value of c, as we have seen hapo kwenye solution yetu. So finally you put it in good mathematical terms, where there's a half is a square root, where there's 1/3 is actually a cube root, like that. But as far as this is concerned, it's just a half, -half, so you can put it in mathematical terms. I believe you all know where all this is coming from. When it is a certain quantity power -1/2, when we have fractional exponents, actually these are roots. If it is what stays here is actually the one which will stay outside the root here. So since it's negative, it means it was 1/x, so that 2 comes here. If it was 1/3, then this becomes 3. If it was positive x power +1/2, then it could just be a normal square root power x, not power 1. I mean not the square root of 1/x, because it is positive. It's just a revision for all those who are having trouble with the mathematics,